Hey students, how you doing today? I hope you're having either a good Monday night or a happy Tuesday in class. Anyway, today's lesson is about geometric series. Last Friday, or over the weekend or on Monday, depending on when you watched it, all those were arithmetic series, and we had the equations that were shortcuts to get us through arithmetic. These equations are meant to get us through geometric series. We've used this equation and getting it set up that you take the first term, whatever rate you're multiplying by to get from number to number to number. And if you're using this form of the equation, then the sum of that series will always be equal to A1, the first term, times the quantity of 1 minus the rate to the power of n, all divided by 1 over r. And the number 1 here is a perfect example of a problem that you're going to be using both of these equations in order to figure out this Sn. Assume that this 500 is your A1 and it says A15, so that's 15 terms in the series, so we're looking for S15, and that's equal to A1, which is 500, times the quantity of 1 minus, well, what are you multiplying this by to get from 500 to 300 to 180? And you could always, a good way of doing that is just going the second number divided by the first number. 300 divided by 500 is equal to 3/5. So that's your multiplier. You're multiplying by 3/5. And then check it for consistency. 180 over 300. Out of each of those, you could divide out a 60, and you'd get 3 over 5. You could try it out for a couple more, but you're going to continue to find that you're getting 3/5 every single time. So that is our multiplier. So I'm going to put 3/5. And then this is being, we're looking for S15, so 3/5 is being raised to the 15th power, divided by 1 minus 3/5. As you can see, this problem can be a calculator nightmare. So you're going to be using a scientific calculator. Make sure that you're inputting it right. Whoever you are, pick up your calculator. Make sure you're able to get the same answer I am with this. Let's see. So inside the parentheses, first thing I have to do is this 3/5 to the 15th power. So 3 divided by 5 will give me 0.6. And then I raise 0.6 to the 15th power. And I get this decimal. Now you need to keep it exact, so I'm going to go 1 minus that decimal. 1 minus the answer. It gives me that. So then that's what's going on inside the parentheses. So then I'm going to multiply that by 500. And I'm getting 499. And then this is divided by 1 minus 3/5. 1 minus 3/5 is 2/5. 2/5 is 0.4. So I've got this number here divided by 0.4, and I got 1,249 point. I'm going to go with 3 decimal spots of accuracy here. 412. These problems might end up ultimately have a long decimal. And because this was such a big calculation, I recommend running through it twice just to make sure you did it right. 0.6 to the 15. 1 minus that answer. Take that, multiply it by 500. Oops. Shoot. 0.6 to the 15. You make a mistake, you got to start over. 0.6 to the 15 gives me that. 1 minus that gives me that. Take that, multiply it by 500. Gets that. Divided by 0.4. Alright, I got the same number back-to-back tries, so I'm going to assume I did it right. That's the answer to number 1. That's what it added up to. Unlike the arithmetic series, you don't actually need to know what A15 is. It's kind of interesting. Alright, let's take a look at number 2. In number 2, they actually do give me the last number, but I guess I got to figure out what that number is. So I'm looking for S, I don't know, like in the previous problem, I knew I was looking for S15 because it said A15, so S15. But here, it doesn't, I don't know what S number this is, so I got to figure that out using the AN formula. So if AN equals A1 times R to the N minus 1, AN is this decimal here, 0.000001024 equals A1, which is 10, times the rate. It looks like each time I'm multiplying by 1/5. So 1/5 to the, I'm looking for N, so N minus 1. Hey, remember logs? We're going to use logs to solve this. Oh boy. Alright, if you remember from using logs, the first thing you have to do is you have to move this 10 to the other side. So you have to do this number divided by 10. So point 1, 2, 3, 4, 5 zeros. 1, 2, 1, 0, 2, 4 divided by 10 gives me even smaller numbers. So it would be 0.12345 1024 dividing by 10. That just moves the decimal spot over. Equals 1/5 to the N minus 1. And then we log both sides. So I have log of 0.0000060 1024 equals log of 1/5 to the N minus 1. And as you recall from logs, that allows you to move this exponent to the front, so it becomes N minus 1 times log of 1/5 equals this giant number still down one level. You then divide both sides by log of 1/5. And this is where the problem is supposed to like make a nice turn. One thing you can count on with these problems is when you're looking for N, if you don't get an integer, something's wrong. So let's try this out. So I have log of 0.log of 0.12345 1024 divided by log of 1/5, which is essentially 0.2. And I hope, well, fingers crossed, it's going to give me a happy answer. 10. 10. So that means 10 is equal to N minus 1. You add 1 to both sides, which means N is equal to 11. Like I said before, if you get a decimal here when you do this division, something went wrong because N is the number of term, and you cannot have a decimal value when it comes to a term number. What's the 5th number of the series? I get that. What's the 5.3rd term of the series? That doesn't make sense. So what we're looking for here is S11. And now I can use that formula. S11 equals A1, which is 10, times 1 minus R, which is 1/5. That 1/5 is being raised to the nth power, and that N is 11. Close that, divided by 1 minus 1/5. And then, same thing as the last problem, pick up that calculator and get yourself a decimal approximation. When you look at it, 10 plus 12 plus 0.4 plus the decimal gets really small pretty quick. The answer should be 12 point something. Maybe 13, but probably 12 point something. Alright, 1/5, that's 0.2. So, I'm going to put my calculator right here. I'm going to show you all my calculations for how I do this. Zoom out, Elliot. I did. Okay. 0.2 to the 11th power is that. Then 1 minus that. 1 minus the answer is that. Then you're going to multiply by 10 and you get that. And then you're going to divide that by 1 minus 1/5. 1 minus 1/5 is 4/5. 4/5 is 0.8. So the answer divided by 0.8, and I got 12.4999974. So, you know, when you get something like that, 4.99999, that's pretty much, because, you know, the calculator at the end of the day does do some minor, what's the right word? Minor approximations. And if you think 4,99999, that really means that this should probably be 12.5. So I'm going to answer 12.500. To basically, what I basically do is I'm rounding to 3 decimal spots to the nearest thousandth. But I'm curious if the calculator approximated, and it should be exactly 12.5. If you did this on Google, this calculation on Google, they tend to give you a much more accurate decimal representation. Oops. At the end of the day, though, my answer is this 12.500. Any questions on it? Let me know if you have any questions. Okay, next one. What do you do when they actually give you a sigma notation that is already in geometric mode? Just use the formula. Sn, it's going from 1 to 20, so there are going to be 20 numbers in this series. S20 equals A1. What happens when you plug 1 into this? Well, let's see. 1 minus 1 is 0. 6 to the 0 is 1. 2.1 times 1, that's 2.1. So 2.1 times 1 minus r. What are we multiplying by to get from number to number to number? It says right here that we're multiplying by 6. That is being raised to the nth power. And in this case, n, it says, is 20. So 6 to the 20. Yikes, that's a big number. Divided by 1 minus 6. Okay. Here we go. 6 to the 20 power. Giant number. If you look, it says times 10 to the 15th. Like, this is a scientific notation. It's such a big number. Excuse me. All right, then 1 minus that giant number. It'll give you a negative giant number. Times 2.1. Still negative. Divided by, it's dividing by 1 minus 6, which is negative 5. So that's how that negative number is going to become positive. And, okay, you got to be careful here. I got this giant number. It goes like this. 1.536, if we round to the nearest thousandth with this decimal, times, and then it says times 10 with a little 15 here. So that's times 10 to the 15th power. That's a good enough answer for me. Scientific notation. And if you think about it, it is going to be like that, because when you get 6 to the 20th power, that number is huge. So that happens with these. All right, last one. And this problem's an interesting one. That's why we're doing it last. I'm looking for A1, but it gives me R and it gives me S10, which means it gives me N. So this is basically algebraically solving for A1. So S10, so 15.984375, that is S10. That is equal to A1, which is what I'm looking for, times 1 minus R 0.5 to the nth power, but because it's S10, it's 1 minus 0.5 to the 10th power divided by 1 minus 0.5. All right, let's see. Algebraically, we need to solve for A1. 1 minus 0.5, that's 1/2. So the first thing I would do is I'd multiply both sides by 1/2. And so that would give me A times 1, A1 times 1 minus 0.5 to the 10th power equals this thing times 1/2, which is the same thing as going divided by 2. So 15.984375 divided by 2 gives me 7.992187.5. And now I'm going to divide both sides, because this is A times this giant thing here, or this tiny thing, this thing, whatever it is. So I'm going to figure out what this thing is, and then I'm going to go this number, 7.992187.5, divided by that thing. So first, we got to figure out thing. 0.5 to the 10 should be a very small number. Then 1 minus that very small number should give you something pretty close to 1, like 0.999 stuff. All right, now we're going to go this number divided by thing number. So 7.992187.5 divided by thing number, which is my previous answer. Oh, and what do you know? It gave me an answer of 8. That's a good indicator. That's one thing that's nice about these problems, is you get this huge ugly decimal, but then when you solve out the algebra, you actually get an answer that works. It's nice because it gives you confidence that you're doing the problem right. Anyway, a little bit longer of a lesson today. Geometric is a little bit more complicated than arithmetic, so these problems will take a little bit longer. They're more decimals, more hard algebra. Anyway, if you have any questions, let me know, everybody. I love you. I'll talk to you soon. Bye-bye.